What up, mathletes? Whoop, whoop. All right, let's get into this. Today is a distributive property, and your learning target is, I will factor polynomials using the distributive property. I will factor polynomials using the distributive property. Okay, so warm up. Go ahead and name the greatest common factor of each set. And I'm going to write it a little differently, but pause this. Go ahead and do it. Ready, set, and I'm going to do it. Between 6x and 12y, the only thing I can take out is really a 6, because I'll have 6 times x, right? And then for 12y, it would be 6 times 2y. For 16a cubed and 4a, I can pull out a 4a, because it's going to be 4a times 4a squared for 16a cubed, and 4a times 1 for 4a. There's a reason I'm writing it like this, guys. I'm just showing, if I multiply those out, 4 times 4 is 16, a times a squared is a cubed, right? So look at this. For 15g squared h, 10gh squared, I'm going to say, what can I take out between 15 and 10? I can take out a 5. How about between g squared and g, I can take out a g, h and h squared, I can take out an h. And so for this one, when I take 5gh out of 15g squared h, 5 out of 15 makes 3. G out of g squared leaves a g, and then h out of h, that's gone. For 10gh squared, 5 out of 10 is going to leave 2. Or first I got to write 5gh, sorry, 5gh. And then times 2. The g's there, and out of h squared, I'm left with an h. Last and longest one between these, let's see, between 3, 12, and 9, I can pull a 3 out. Between r squared, and r, I can pull an r out. S, oh, there's no s in this term, can't pull an s out at all. T cubed, t and t, I can pull out a t, so 3rt. When I pull that out of 3rst cubed, 3's gone, r's gone, but I'm left with an s and one of the 3 t's, so I'm left with 2 t's, t squared. 3 out of 12 is 4, r out of r squared is r, and t out of t leaves nothing. So it's going to be, oh, I gotta write that as though, oh my goodness, keep doing this, 3rt times 4r. And then I better write down quick, 3rt, and let me look at 9rs squared t. 9rs squared t, 3 out of 9 is 3. R out of r, that's gone. No s is gone, so I have s squared, and t takes away the t. There we go. Boom. Look at that. Now we got some. Okay, let's do this. So factoring is the process of expressing a polynomial as a product of monomials and polynomials, and factoring by grouping is what we're going to really be doing today, using the distributive property to factor some polynomials having 4 or more terms. Okay, pause this as needed. I'm moving on. Ready, set. We're going to roll on to the next. Okay, so I'm assuming you wrote those down. We're going to talk about the distributive property. What if I had 3y times 2y plus 5? We're going to distribute this 3y, right? So I'm going to have this equals 3y times 2y, and then it's a plus 3y times 5, which equals 3 times 2 is 6, y times y is y squared, 3 times 5 is 15, plus 15y. Boom. Nothing too bad, right? Now I want to say, what if I do reverse? When we do it in reverse, it's called factoring. So we're going to start out with 6y squared plus 15y. We should know what it goes back to, but I want to show you the process. So I'm looking at this saying, what can I pull out of both 6 and 15? I can pull a 3 out. How about between y squared and y? I can pull a y out. When I pull a 3y, a 3 out of 6 leaves me with 2. A y out of y squared leaves me with y. Perfect. And then plus, again, we're pulling a 3y out. And 3 out of 15 is 5. And then y out of y is just left like that. So notice they both have a 3y in common now. So I can pull that 3y out. This equals 3y times whatever's left in here, 2y plus 5. Look at that. Okay? So let's do that down here. Let's look at the 49x cubed minus 21x squared. 49 and 21, what do they have in common? A 7. And x cubed and x squared, I can pull an x squared out. Okay? Times, when I pull 7 out of 49, I'm left with 7, and x squared out of 3 leaves me with x. Minus 7x squared times what? Well, I pull a 7 out of 21, and I'm left with 3. X squared out of x squared, I'm just left with 3 then. So now they both have a 7x squared in common. I'm going to pull that 7x squared out, and I'm left with, on the inside of the parentheses, 7x minus 3. That's the factored form. So look at this last one right here. What can I take away from, or factor out of a 15, 6, and 12? I can factor a 3 out of there. What can I factor out of g squared, g, and g? I can factor a g. What can I factor out of h squared, and h? An h. So it's 3gh is the factor. Now let's pull a 3, factor 3 out of 15, I'm left with 5. Factor g out of g squared, I'm left with g. H out of h makes it disappear. And then it's a minus sign there, so I'm going to put minus, and then 3gh times 3 out of 6 leaves a 2. G out of g, that's gone. H out of h squared leaves an h. And in the very last deal here, we have a plus 3gh, and a 3 out of 12, it's going to be 4. G out of g, that's gone. H out of h, that's gone. Just times 4. Now, each of these have a 3gh in common, so I'm going to rewrite this as 3gh times 5g minus 2h plus 4. Boom. Now, let's look at this last one right here. It says, in fact, pause this if you can do it. It just says a rectangle has an area of 18x squared plus 36x. Factor to find an expression that represents the area of the rectangle as a product of its length and width. In other words, we're going to factor this, so we're left with the length times the width. Ready, set, go. Pause this if you need more time. What goes into both 18 and 36? I've heard some people say 2, some people say 9. Really, it's 18. I can pull an 18 out. How about x squared and x? I can pull an x out. When I pull 18x out of here, I'm just left with times x. So plus, and when I pull an 18 out of 36, so it's going to be 18x times 18 out of 36 leaves 2. And x out of x, that's gone. So this becomes 18x times x plus 2. There you go. Again, pauses as needed. I want to put up here what needs to be done in factoring by grouping. I've kind of written it out myself. Let me zoom it in a little bit for you. Take a minute. Pause this, write it down. I'm going to move on because you have the power of pause, but go ahead and do so. All right. Okay, I have moved to the back page, and you've written down hopefully all the good stuff. Which, by the way, I probably should walk through this a tad. I just kind of moved it and didn't talk about it. Polynomial can be factored by grouping. Only if, that means if and only if these conditions exist, 4 or more terms. Terms have common factors that can be grouped together. There are at least 2 common factors that are identical or additive inverses of each other. And here's the example. Notice how we moved around the AX and the BX. We're going to group those together and pull an X out. We group the Y's together, pull the Y out. We're left with x plus y times a plus b. I'll give a better example right here. Don't worry, guys. I'm just making a video, so now you see how the magic happens. So look right here. Boom. I'm going to go ahead and just factor these together and see what happens. Are you ready for this? What can I pull out of here? I can factor out an x squared. And what am I left with? Take an x squared out of x cubed, I'm left with x. X squared out of 7x squared is left with plus 7. And then I'm going to have plus. Just ignore the barbecue sauce there on the paper. It's all good. What can I take out of a 2x and a 14? A 2. And I'm left with x and a plus 7. Look at that. They both have an x plus 7. Watch this. Now I can factor that x plus 7 out and multiply that times the x squared plus 2. Boosh! And that is your fully factored by grouping example. With that said, peace out!